continuation of your module 5. All right, so can you guys see my screen now?
Yes, sir.
All right, that's good. So this is where we've stopped last meeting, step work number 8. So here's now the continuation, which is the applications of functions or the mod. Okay, so is there anyone here who knows how mod or modulus function work? This one. Anyone? Do you guys have any idea what is this mod?
Sir, parang medyo lang, sir.
Medyo lang. Okay, how
Yes,
about the
sir.
others? Completely nothing.
Medyo lang, sir.
Medyo lang. Alright, that's good. So this one is actually super similar with our division. Alright, there you go. Okay. So as you guys can see right here, this one refers to the remainder of the division written as x mod y. So as you guys can see, if we have division, we have the symbol or the symbol. So let's say if you're going to use this symbol, we're trying to get the integer part and then the remainder part. So basically everything, right? We're trying to get everything. Like for example, if we have 5 divided by 2, so this will give you, where is my calculator? This will give you 2.5. Yeah, this one's 2.5. So I don't need my calculator now. Okay. So as you guys can see, we are getting the integer part, which is the whole number, and then the remainder part at the same time, or the decimal part. But when it comes to mod, okay, we have this symbol, okay? So it is the flip version of our division, okay? So if we have 5 modulus or mod 2, then you will get just the remainder, which is 1. All right. So how about if we don't have a remainder? So 6 mod 2 or 6 divided by 2 is actually 3. So 3.0. This one is in division. So, oops, sorry. This one should be in modulus, okay? So this is the symbol for modulus. So if we're going to use division, so 6 divided by 3 will get 2, right? Yes?
Yes, sir.
Or basically this one is 2.0
Yes,
to be
sir.
exact, if you're going to list the integer part and then the remainder part. But if you're going to, use the modulus or the mod, okay, we're just getting the division part. All right, let's change this one into mod. Okay, so as you guys can see, this one doesn't have a remainder, so this one will give you a result of 0. Okay, so the same with letter B, 5 mod 1 is also equals to 0. And for letter C, so 8 mod 12, if the numerator is not divisible by the denominator, just copy the numerator. Okay, this will be your remainder, and that will be your answer for this expression, which is equal to 8. And another thing in here is if we have an odd number, no matter how big it is, as long as it can be divided by 2, okay, or as long as it's divisible by 2 or even, okay, it will always give you a result of 1. Okay, so try to divide this one. This will give you a remainder of 1. So were you guys able to understand how modules work?
Yes, sir.
Sir.
All right. So another thing here is when we're using modulus, okay, take note that your x and y should be positive integers, or in other words, you only have z plus, okay? If ever you have negative, well, I guess that's a different scenario. But in most cases, when we're using mod, your x and y are always positive integers. Right? So again, if your numerator cannot be divided by your denominator, so just copy your numerator as it is. All right. So next, we have here an example wherein let f be the function from x, wherein x is equal to 0, 1, 2, 3, 4, to x defined by this function. Okay, so we have this function for your y. Okay, so this is already your x, and then you're now looking for your y. But before we can solve for your y, we have this formula or expression. So let's answer this one. Right, so as you guys can see, we already have our x's, which is this 1, 0, 1, 2, 3, 4. Now we're trying to look for your y, which is this f of x. So if we have, okay, we'll just use notepad, since this one is a lot easier. Function is equal to, so how many do we have? How many pairs? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So for our x, we have 0, 1, 2, 3, 4. 0, 1, 2, 3, and then 4. So the question here is, what are our y's? So if we have a value of 0 for our x, so just substitute that 0 to this x. So 4 times 0 is 0. And then 0 mod 5 is what, guys?
0, sir.
0 mod 5
Hindi ba 0,
is
sir?
also 0. Yeah, that's correct. How about 1? 4 times 1. So 4 times 1 is equal to 4. And 4 mod 5, what is the result?
4.
Right, very good. How about if it's 2? So 4 times 2 is 8. 8 mod 5, what is the result?
3. Tama ba, sir?
3. Yeah, that's correct. How about if it's 3? So 4 times 3 is 12. 12 mod 5, what is the result?
2.
All right, very good. So as you guys can see, we're only getting the remaining numbers, okay, which is the remainder. Last one, 4 times 4 is 16. So 16 mod 5 is equal to
1, sir.
yeah, very good. So here's now the set of ordered pairs for this function. All right. So second here is draw the arrow diagram of this function. So this one is super simple. So just list all of your x and then all of your y's. So we have 0, 1, 2, 3, and then 4. And then we also have 0, 4. Yeah, it's also complete. So 0, 1, 2, 3, 4. So first we have the 0, 0. And then we have the 1, 4. Then we have 2, 3. Then we have 3, 2. Oops, 3, 2. And then we have 4, 1. Oops. So this is now your arrow diagram for this function. All right. So another question here is f 1 to 1 or onto? So first question first. Is this 1 to 1?
Yes.
Yes, sir.
Yes. Okay. So this is 1 to 1. Auto. So yes. Okay. Is this onto? So coming from Miss Galigues, so this is also onto. So when you say 1 to 1, all of your domains must have one partner only. Okay, and then all of your y's must have one partner only. So some of them can be unused as long as our domains has all of their partners. And then for the unto, all of them must have a partner. All right. So what do we call this one again if we have a one-to-one function and an unto function at the same time? Anyone who can remember? What is that function again if we have a one-to-one and unto at the same time? Starts with letter B. Anyone? Can't you guys remember? Next is letter I. Next is J. Still no one? No one can still remember what is that a function called?
Oh my God.
So we
Bijection,
call
sir?
that one bijection. Okay, so very good, Miss Galigas. All right. So you guys might be wondering, Miss Galigas is answering through chat, so he's directing her message to me. All right, so this one is a bijection. All right. So the next one here is hash functions. So hash functions is a function wherein it is the way of our computer wherein you can store his data to this cell, this cell, this cell, this cell. All right. So basically, this is a way of computing things on where he will put your data on his storage. So as I guess you can see, this one takes a data item to be stored or retrieved by computing the first choice for the location for the item. So we have this symbol H for hashing, and then your N is the count of data that you're going to store to your computer. So depending on the count of your data, so it will be your N in here, which is mod 11. So why do we have 11 in here? Because so basically it will count the count of characters of your data. For example, we have 15 data, so this one will become 15. If we have 20 data, this one will become 20. All right. So that's how our computer uh, do a hashing function. All right. So basically, this one has a memory from 0 to 10. So why 0 to 10? So since we have 11 data, so you're going to start with 0, so up to 10 only. So this one is already a total of 11 cells, right? So for you guys to understand what is this hash function, so let's have an example. So we have this following values in the memory using hash function. So as you guys can see, we have a data of 15, 558, 32, 132, 102, 5, and so on and so forth. Okay. And it says here that you have 11 cells initially empty, right? So we have here the solutions. So these are your cells. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 11. This one is up to 11. All right. So I missed one box. Anyway, so this is the solution for on how you will put those data on each cells. So we have here 15 mod 11. So your 15 here is your data. Okay. So 15 mod 11, and then your 11 here is the count of your cells, right? So 15 mod 11 is equal to 4. So just look for that cell 4. So 0, 1, 2, 3, 4. So just put there your data number 15. And the next one here is 558 mod 11, and then you will get a remainder of 8. So just look for the cell number 8. Put there your 558. And then for 32 mod 11, so as you guys can see, we have a remainder of 10. So just put there the data, which is on cell number 10. And then 132 mod 11, so if you're going to compute this one, you're not going to have a remainder. So just look for the 0 cell, right? Which is now your 132. And for the 102 mod 11, we have a remainder of 3, so just look for the third cell. I mean fourth, since this one is your first, second, third, and fourth. And for the last one, 5 mod 11, so this one is not divisible by your divisor. So just copy your numerator as your remainder. So 5. So just look for the 5 and then put there the data 5. All right. So as you guys can see, we still have remaining empty cells. So you can skip them as it is because we only are, or we were only given 1, 2, 3, 4, 5, 6 datas. Okay. So we still have 5 remaining free empty cell. So did you guys get this one so far on how did we put our datas on each cell?
Medyo, sir. Medyo.
Medyo. Anyway, just imagine this one as your memory. Okay. So on your memory, we have one cell for your datas. Okay. So we have 11 cells total for this example. And then we have 6 datas wherein you're going to store your data or those datas on your cells or memory. All right. So we have here actually a problem, like for example, collision. Okay. So what if we have the same data occupying the same cell? Like for example, this one, 4,257 mod 11, wherein it will give you a remainder of 4. So as you guys can see, your fourth cell is already occupied. Okay. So in storing a data, this one is a first come, first serve basis. Okay. So the second one that will occupy this data will look for the highest unoccupied cell. Okay. So as you guys can see, the next higher than number 4 is 5 or the 6 cell. But since this one is already occupied, so you have to look for another cell, which is number 6, which is empty. So instead of putting your 4,257 in number 4 and number 5, so you're going to put your data or that data in here. All right, so this is what we call the collision resolution policy to avoid, having multiple datas on one cell, which will give you an error, of course. So one cell, one data only. That's the policy when it comes to storing a data. Right? So they must have their own unique IDs. So did you guys understand this one now? Sir, what if naulit yung remainder na 4? Like for example, if we have another remainder 4, let's say another data wherein you have a value or a remainder of 4. So since your number 6 is already occupied by this 4,157, then just look for another cell, which is the number 7. And if this one is occupied again, just look for another one, which is number 9. If this one is occupied again, just go and then you will go back here now. And then of course, it will now place your data to your number 1 until all of those cells will be filled out by your datas. All right. So don't worry. I won't be giving more datas than the cell available for your seat work or exam, right? So maximum count of datas will be equal to your number of cells. So are we clear on this one now? Go guys.
Yes, sir.
So it is okay now for Ms. Villegas and Mr. Lepson. How about the others? Were you guys
Yes.
able to follow? Where is
Yes,
the
sir.
part that you're confused? Right? So I guess none. Anyway, if ever you guys have a question, or if you don't feel like asking your question right now, so feel free to message me on my Canvas account or Facebook account. All right, so here's your seat break number 9. So I will leave the analysis part with you guys since we don't have enough time anymore. So if ever you have clarification or questions regarding with this one, so feel free to message me. All right. So again, you can do this one on your Microsoft Word or handwritten. Okay. So the next one here is floor and ceiling. So to make it short, when we say floor, you will round down a certain number. Okay. Of course, it will be a whole number or a decimal number. Okay. And when we say ceiling, okay, this is the what we used to do. We round up a certain number. So it could be a whole number or a whole number with a decimal. All right. So as you guys can see, this is the symbol for the floor. Okay, we have this underline below. Okay, and then the symbol X. Right. So this X is any number. And for the ceiling, we have this symbol. So it's an inverted floor. So as you guys can see, we have here now the underline, okay, which is like symbolizing the ceiling. Okay, when we say ceiling, you look at the top. When we say floor, you look at the bottom, which is this one. All right. And as you guys can see, when we say floor, okay, we round down a certain number. So your 8.3 will be round down, will become 8, and your negative 8.7 will become negative 9. So it becomes more lesser. Okay, so do not get confused on this one. We didn't round this one up, but we did round this one down. All right, so negative 9 is lesser than negative 8.7. Right, and for the ceiling, of course, we're going to round up a certain number. So this one, 6 will retain as it is because it doesn't have a decimal. But if there is at least a very small decimal that I have in that number, like for example 9.1 or 9.001, if it's inside a function of the ceiling, then it will round up to the next whole number, okay, which is of course 10. So your 9.1 will become 10. So the same with negatives. Your negative 11.3 will be round up to negative 11. Right? So your negative 11 is higher than your negative 11.3. And then for negative 8, will stay the same as it is since it doesn't have a decimal. So were you guys able to follow what is the floor and ceiling does in our numbers?
Yes, sir.
Yes, sir.
Right, that's good. So here's a graph for the floor. So focus on my cursor for now. So as you guys can see, this is the floor or the final number for that certain range. So if we have 2.0 to 2.9, okay, it will fall on your or on our 2.0. Okay. So even though it reached 2.99999, still, okay, it will be round down since we're talking about floor. So your uh, number here or the result here is 2. Same with the next one. If we have 1.0 to 1.9, you will get 1 only. We have 0.0 to 0.9, it will round down to 0, etc., etc. All right. So your negative 2.1 will become negative 3. So if you're going to plot this one, you're going to plot it right here. Okay. So this is the vertical, I mean diagonal line of this plot. Okay. So these are their final numbers. So were you guys able to follow this graph with the floor?
Mhm. Yes, sir.
Yes, sir.
All right. So if we have graphs for the floor, we also have the graph for the ceiling. So as you guys can see, it's just the opposite of your ground. So before it's in the left side, right now it's on the right side. So if we have a smallest, let's say 1.1 or 1.001, it will be round up to 2, okay, since we are in a ceiling. Okay, so no matter how small your decimal is, it will round up to the next integer number. Okay, so if you have 0.1, it will be considered as 1 already. If you have negative 0.9, it will be considered as 0. If you have negative 1.9, it will become negative 1. If we have negative 2.9, it will become negative 2. And then again, if you're going to plot this one, so this is where you're going to plot it. Okay. All right. So were you guys able to follow this graph for the ceiling?
Yes, sir.
Yes, sir.
All right, it's good then. So let's have a final example. So here's plotting the graph. So plot the graph of the function f of x is equal to 5 plus 3. And we have here ceiling x point 1. So what are the values of our x? So your x is ranging from negative 5 to positive 5. All right. So let's do this one. So remember, your f of x is actually equal with your y. All right. So this one can be seen with our past example, which is for the graph, this one. So as you guys can see right here, we have the x values, and then for the y's, your f of x is actually equal with your y. Right? So if you're going to plot it, your f of x are your y's. All right, so let's answer this one now. So first, I will list all of the ordered relations. Right. It's kind of difficult in here. So we'll just use this notepad. 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. So our x are ranging from negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and then 5. So we're now looking for our y's if we have those individual values of x. So if we have negative 5, so just substitute this negative 5 into this x. So 5 plus, this one first. 8. So negative 5.1 will become, so remember we are in ceiling, so your negative 5.1 will be round up. So it will become negative
5.
5. Right.
Negative
How
5.
about if we have negative 4? Sorry. So negative 5 in here. So negative 5 times 3. Okay, so you have to compute this one. So negative 5 times 3 is negative 15. Plus 5 is negative 10.
Negative 10.
Right. How about if we have negative 4.1? What is the value of our y? So negative 4.1 will become negative 4. And negative 4 times 3 is negative 12. And negative 12 plus 5 is
Negative 7.
negative 7. All right, so since we don't have enough time anymore, so I'll just follow, okay, the one, the pattern. Okay, so as you guys can see, we have here negative 10 to negative 7. So their difference is actually negative 3. So it just keep on incrementing by 3. So negative 7 will become negative 4. -4 will become -1. And then -1 will become +2. But in here, okay, so it's a different scenario already, since 0.1 will become 1. So 1 times 3 is 3. And then 3 plus 5 is 8. So we don't have a pattern here anymore. So it was cut. But in here, just keep on incrementing by 3 again. So 1.1 is 2. So 2 times 3 is 6. 6 plus 5 is 11. So as you guys can see, it incremented by 3 again. So 11 will become 14. 14 will become 17. And then 17 will become 20. And 20 will become 23. All right. And yeah, so here are our list of ordered pairs now. So as you guys can see, if you're going to plot this one, so here's your x, here's your y. So we have -10 to +10. Oops, -5 only. -5 to +5. And then our maximum number for the y is 23, and then the minimum is -10. So I'll just assume that this one is your +23, and then this is your -10. So just plot them. So -5 and then -10 is right here, and -4 and then -7 is right here. So let's just assume that it's diagonal like this until you will reach this +5, 23. All right. So that's how we plot this function. F of x is equal to 5 plus 3 x, that one if we have this range of number. So were you guys able to follow somehow?
Yes,
Yes,
sir.
sir.
All right, so yeah, you still have 1 minute and 20 seconds. So that's it for this module 5. So the coverage of your exam is module 3 to module 5. And then your exam will be on this coming Saturday. All right, so please finish all of your activities until this coming Saturday. All right, so again, you can do this one Microsoft Word or handwritten. So if ever you have a question or clarification, so please message me on my Facebook account or Canvas. All right, so yeah, that's it. Any other concerns so far?
None, sir.
None,
All
sir.
right. Okay, so yeah, that's it. Goodbye, and thank you guys for coming. So see you guys whenever I see you.
Thank you, sir.
All
Thank you.
right, so goodbye, and good luck to your final exam.